Okay, we're going to do basic integrations. These use formulas, integration formulas of course, that we've seen so far. For example, if you want to do the integral of 3x plus 7 to the 5th power dx, you should let u equal what's being raised to a power. That's usually good advice. Except if what's being raised to the power is x or y or z. If it's more complicated than that, let it be called u. Well then du will be 3 dx. Well, this portion here, that will be u to the 5th. You have to justify every piece. Now, if only I had a 3 by the dx, well then that would be du. But I don't have this 3, so I have to put a third in front. Once I put the third in front, then if I put a third in the front, then I do have the 3. So it's just the integral, it's just 1/3, the integral of u to the 5th du. So this is a very standard integral. It's u to the 6 over 6. Remember, the integral of u to the n du is u to the 1 more, divide by that new power, plus a constant. And you can verify this, take the derivative of this, and you should get u to the n. Plus c, 1 times u to the 6 is u to the 6 over 3 times 6 is 18 plus c, and I just substitute what u is. U is 3x plus 7. A quick check would be take the derivative of this and make sure you get 3x plus 7 to the 5th. And we'll do that. So over 18 steps, you have a function to a power. You keep the function the same, bring down the power, make the new power 1, and then multiply by the derivative of what's inside, which is 3. So 6 times 3 is in the top, which is 18, and that's the 18 on the bottom. So we're left with 3x plus 7 to the 5th. It is exactly what was in the box on the top left. So it checked the. Okay, let's try the next one. Suppose you have the integral of 2 dx divided by 7x plus 5 to the 11th power. What I would do is, just my style, I like to bring the constants out in front immediately. If I need a constant, I'll put the one that I need in there. If I need a 2, well, I can put the 2 back. I'll let u be what's being raised to the power, 7x plus 5. So then du will be 7 dx. The bottom, well, that's u to the 11th, with a 2 in the front. The bottom is u to the 11th. The numerator dx, well, if I only had a 7 dx, then I can call it du. Well, I'll put the 7 in, but I have to divide by 7. So what's in red is things that we add. This piece is du. And the 7 goes on the bottom. I justified every piece. There's nothing left over. There's nothing that I needed that I didn't have. Right now what I'll do is I'll bring the u to the 11th to the numerator as u to the negative 11th du. Well, this is u to the n du. By the way, when I said the integral of u to the n du is u to the n plus 1 over n plus 1 plus c, this is assuming that n is not negative 1. After all, if n is negative 1, we'll be dividing by 0. And n is not negative 1, it's negative 1. So I add 1 to the power, and I get 10, and then negative 10 plus c. A little bit, 2 goes into 2, 1, 2 goes into negative 5 times. The numerator is positive, the denominator is negative. The final answer, I'm going to put over here, please, negative. Let's see. The 1 on the top, this times the 5 stays. Why didn't I say the minus 735? Why didn't I say the minus? We dealt with the sign. And the negative 10 goes on the 10. So the final answer is 1 over 30 times u to the 10. And no random guessing. So on your paper, on the board, says where u is. U is plus 5. Okay, plus c. Take the derivative and you should get 7x plus 5 to the 11th power. That problem is done. Try the next one. Suppose you have the integral of x times sine of x squared dx. Unless the angle is just a, b, c, x, y, z, you should let u equal angle. And if everything in here were u's, then I would let v equal angle. Well, if u equals x squared, then du is 2x dx. This here is sine of u. That is the sine of u. X dx, well, that's part of du. I just need a 2. Okay, so I sneak in a 2 and I bring out a half. So then this times that, 2x dx, according to that symbol, 2x dx is du, with the half in front. And I justified everything. There's nothing here that I didn't account for. But this is a straightforward integral. Supposed to know the integral of sine of u. It's negative cosine of u plus c. So the answer is negative cosine of u over 2 plus c. And u is whatever it is. In this case, it's x squared. Take the derivative of this, you should get x sine x squared. You should get x sine squared x. Let's try another one. Suppose you have the integral of sine x e to the cosine x dx. Should usually let u equal the power of e. cosine x. Well then du is negative sine x dx. Well this piece here, that's e to the u. That's e to the u. And sine x dx, well, that's almost du. I just need a minus sign. Now, this times this, that's du. If I put a minus inside, I have to put a minus outside. I'm really multiplying. These minus signs are really negative ones. Negative 1 times sine x dx. Okay, and like I said, this times this, well that's du. There's the minus sign. The integral of e to the u du is just e to the u plus c, where u happens to be what it happens to be. In this case, cosine of x. There's your answer. Don't forget to write the plus c, else you lose a point. Each and every integral problem. You have 10 integral problems on an exam, and you get everyone right except the plus c's. You only get a 90 because you lose 10 points. Suppose you have 1 plus e to the x. Let's cube this and divide it by e to the x. Suppose you have that. Dx. Interesting. Okay, suppose you let u equal e to the x. Okay, well then du will be e to the x dx. Okay, let's see what happens here. In fact, maybe I'll let u be 1 plus e to the x. So this portion here, that's the u cubed. And actually, maybe I don't want to do that. Let's just let e to the x, u be e to the x. For the record, if I let u equal 1 plus e to the x, the differential would still be that. So it's 1 plus u all cubed. And the bottom is just u. Okay. But now we just have dx. Now keep in mind that in our case, du happens to be u times dx, because that's u. Well, I can put a u in the top, so long as I put a u in the bottom. Notice I didn't put anything outside. I didn't put 1 over u on the outside. You cannot put variables to the right of their integral sign and variables in front. No. But you can multiply by u over u. Okay, well then this piece here, according to my definition down there, that's du. And the bottom is e to the x, which is u times another u. So that's u squared. Now, I guess I'll solve this integral by cubing the 1 plus u. And I'll get 1 3u plus 3u squared plus u cubed. That's 1 plus u all cubed divided by u squared. And all of this gets multiplied by du. And now I'm just going to do the division. I'm going to divide each term on the top by u squared. I divide 1 by u squared, 1 over u squared, but I'll write it like that, plus 3u over u squared. Well, that's 3 over u. I'll leave the u in the bottom. I'll explain why in a moment. 3u squared divided by u squared is just 3. And u cubed divided by u squared is just u. So this is what I really want to integrate. The first integral is u to a power. You add 1 to that power, divide by -1. Plus this integral. I'll factor the 3 out. The integral plus 3 over u du is 3 times integral of du. But you're supposed to know this integral. ln, the absolute value of u. So it's 3 times ln of absolute u plus 3 is 3. The integral of u is over 2. Because u is in u to the 1. Okay, let me clean. And I'm going to erase what goes, but remember it was e to the x was equal to e to the x. Okay. This piece becomes -1 over u plus 3u plus 3u u squared over 2. And now all I'm going to do is I'm going to substitute in where u was. It was e to the x. 3 ln absolute value of e to the x. Since e to the x is always positive, the absolute value of e to the x is e to the x. Plus 3u squared. Well, when you square e to the x, you get e to the x. The rule says to multiply those. X times 2 is 2x. Okay. Except that's not a square here. You just get times e to the u squared, which is e to the 2 over 2 plus c. There's the answer. Take the derivative of it and you will get 1 plus e to the x over e to the x. Let's try another one. Suppose you have the integral of secant of 7x times the tangent of 7x dx. Unless the angle is just u or v or x or y, call it u. Let u equal 7x. And then du will be 7 dx. Well, I have the dx. I sneak in a times 7, then I have du. The 1 over 7 stays. This here is, well, let's do this. This is secant of u. This here is tangent of u. And dx times 7 is du. But that's an integral we're just supposed to know. The integral of secant u tangent u, well, it's 1/7 times that integral. And that integral is secant of u plus c. So that's your answer. It's 1/7. The secant of u is 7x plus c. Problem done. Suppose you have the integral of 7x over 3x squared plus 4. the dx is here, just like if you had 2/3 times 7. This is really 2 times 7 over 3. That is, you multiply those two. That's why I always write things like 7x dx. Okay. Is to bring the constant in front. That is that 7. Let's try that again. That 7, I would bring in the front. The derivative of the top is not the bottom. But you know what? The derivative of the bottom is going to be similar to the top. If I let u equals 3x squared plus 4, well then dx will be 6x dx. The bottom is u. That's u. 7, well, that's 7. If I had a 6 in front, well then that's du. I meant to say a 6 on the top. 6x dx du. But if I put a 6 in the top, I must put a 6 in the bottom. And like I said, the bottom was u and not 6. That's called a typo. The bottom is u, and that's an integral we're supposed to know. 7/6 times this. Well, that's ln of the absolute value of u plus c. And that's u. Since x squared is at least 0, it could be 0, but it's never negative, it's 0. When you multiply it by 3, it'll be 0 or more. But the instant you add 4, it'll be more than 0. This is at least 4, which says to me that I don't need the absolute value bars. There's your final answer. Sometimes you don't need the absolute value bars. And that's exactly when what you take an absolute value of is never negative. It can actually be 0. Four plus 9, and in the top you have x dx. Well, you might want to say, oh, this is simple. Let the bottom be u, and then du is 16x cubed dx. But we may have the dx, but we don't have x cubed. We didn't need the 16. I can always put in the 16. But we need x cubed. So that didn't work. Then you think of the denominator as being the sum of squares. And if it were a minus, then I would say the difference of squares. You can think of the bottom as this being, well, 2 squared is 4, and x squared is x to the 4th. So it's 2x squared plus 9 squared, plus 3 squared. And then what I would do is I would just have a different substitution. Maybe I would start off with u equaling 2x squared. Let that be u. Well, then du will be 4 dx. So I sneak in the 4, and I have to put a 1 over 4 outside. So what I have now is the quarter in front, the 4 4x dx, well that's du. I meant to write 4x dx over here. That's du. And the bottom, well, that's u squared plus 3 squared. U squared plus 3 squared. And then we use trig substitution. I'm going to write the u substitution up here because I need the space where it already is. I need this space. So we're going to make a substitution, a trig substitution. Everything that's being squared has an understood plus sign in front. So the square root of that goes on the hypotenuse. One side gets what's being squared here, which is u, and the other side gets the 3. Now, I can't make a u substitution because this integral already has u's. So I'll make a v substitution. And it turns out that the tangent of v is the most simple statement I can say. It's u over 3. So this tells me that I can also bring this 3 up here. Taking the differential, I have 3 secant v times tangent v times dv, well that's du. Okay, so the numerator, the quarter factors out, the numerator du, well that's 3, which I'll put in the front, 3 secant v tangent v dv. And the bottom, u squared plus 3, u squared plus 9, you could say, well, this side divided by that side. Hypotenuse divided by the adjacent with respect to angle v. Adjacent, that's the secant. Turns out that the secant of v is the square root of u squared plus 9 over 3. I'll put the over 3 on the other side. Now, I don't want the square root sign because the bottom doesn't have a square root sign. So I square both sides. 9 secant squared v. Well, that's u squared plus 9. So the bottom is just 9, which I'll put out in front. 9 secant squared v is the bottom. Well, 1 secant v on the top kills off one of the 2 secant squares on the bottom. And 3 goes into 3 and 9 evenly. So I have 1 over 12 times, well, tangent is sine of v over cosine of v. And cosine of v on top, well, excuse me, in the bottom, that's secant v in the bottom, that's cosine v in the numerator. Okay, so I dealt with that. And then I have tangent v times tangent v. Oh, I already put that in front. I'm sorry. Actually, that times dv. Times dv. And the cosine v's cancel out. And we will try to finish in this corner up here because we're almost done. We have 1 over 12 times the integral sine v. But that's an easy one. That's negative cosine v plus c. Plus c. Negative 1 over sine of v. So now I go back to my triangle here and I ask myself, what's the... Well, it's adjacent over... It's 3 over the square root of u squared plus 9. 3 goes into the 12 in the bottom 4 times. So you have negative 1 over 4 times the square root of u squared plus 9. And u at the very top left u was 2x. So there's the answer. You can square the 2x, and of course you'll get 4x squared plus 9. So that's the last thing I'll state. It's negative 1 over 4 times the square root of 4x squared plus 9. And due to lack of space, plus, I didn't write plus c. But there's your answer. There is your answer. Now, I guess that you can also use octants, but we didn't. Let's try one more. I introduced trig substitution early on. Generally, it's taught as its own section entitled trig substitution. Here's another one. Suppose you have dx over 3x squared plus 4. You just have that. Okay. If you let, now 3x squared is the same. Do I even need to state that? Let u equal 3x squared. Well, then du will be 6x. Excuse me. This bottom is this. What do you square to get 3? Square root of 3. What do you square to get x? X. It's that number squared plus, not that it matters, but 2 squared. This is equal to dx over the square root of 3x, just the square root of 3, excuse me, the square root of 3 times x squared plus 2 squared. So I'm going to let u equal the square root of 3 times x. And then du will just be the square root of 3 dx. Okay. So what we have is, in the bottom, I'm calling what's in the brackets u, so it's u squared plus 2 squared. And in the top, if I sneak in a square root of 3 and justify it by bringing out 1 over square root of 3, the numerator is just going to be du. Now remember, 1 over square root of 3, if I multiply the top by square root of 3, 1 over square root of 3, if I take it and I multiply it by 1, that's square root of 3 over 3, the numerator will be 1 times square root of 3, because we're all experts in multiplying by 1, that's the answer. And square root of 3 times square root of 3 is 3. So we have square root of 3 over 3 factored out. What we need to know is, what is integral? If I'm not mistaken, it's 1 over 2 times the tangent of u over 2. But I don't like to remember that. I have better things to remember. What I'm going to do is I'm going to make another substitution. Make another, call it a v substitution this time. And let's see what we have. We have u squared plus 4 on the hypotenuse. Everything that has a plus, if both things have a plus, then you get the whole thing on the hypotenuse with a square line. One side gets the u, which is being squared. Another leg gets the 2 that's being squared. And here we have the tangent of u. The tangent of u is the tangent of v is u over 2. I'll put the 2 here. So now we have 2 differentiating, 2 secant v, 2 secant squared v. Hope I didn't come on the last problem. 2 secant squared v dv, well that's du. Okay, the square root of 3 over 3 stays. The top is du, well that's 2 secant squared v dv. And in the bottom I have u squared plus 4. Now I can square this, so that will give me u squared and add 4. Or I want this over that is close to what I want. The secant of v, square root of u squared plus 4. If I square both sides, well, the left side I already wrote, squared. The left side will be, well, the numerator loses 9, and 2 squared on the bottom will be 4. Okay, so u squared plus 4 is secant squared v. And if I bring the 4 over, say this is just that. And since I have it plus 4, I can write 4 secant squared. I'll bring the 4 out. And what do you know? Cancel. So then I get 3 over 4, and all that was dv. And the integral of dv is just v plus the constant. Okay, the 2 back. You have the keys to use and use to x's. From this equation here, I know that the tangent of v, I can interchange those two. I can say the tangent of u over 2 is v. The price I pay is I have to inverse. So then this equals v, which is the arctangent of u over 2 plus v is the arctangent of u over 2. And then I look to see what u is. U is the square root of 3 times x. So that's just what I put, the square root of 3. There is my answer. I have one silly, let's put this constant, and sorry about that. The constant goes in front, the square root of 3 over 4, integral, which is just, they have the constant in front, and then I get arctangent of v over, which is, or u over 2. The arctangent, I get that v is of u over 2, and that u was. It was the square root of 3 over 2. Okay, last problem, if I may, to make sure I didn't make a silly or positive. That I near the bottom, the bottom left says 3 tangent v equals u. I did the wrong differential. I integrated the things. Sorry about that. That's wrong. Let's see if maybe we'll retry that. Okay, I mean we made it silly, but you know you should follow everything else that I did afterwards and convince yourself that I didn't make any other errors. Okay, that finishes the section on basic integration.